Good morning, kiddos, and welcome to At Home with APS. We're so glad that you're here with us again today to start a new month. So let's go ahead and start a brand new calendar. So today is Wednesday, July 1st. A brand new month, first day of a brand new month. And since we have a brand new month, I want to go ahead and use a brand new pattern, okay, for this month. So our pattern is going to be red circle. And tomorrow we'll be adding another shape. We're going to add some other shapes to our pattern since we've been spending some time thinking about shapes lately. So today is the first day of our month. Let's go ahead and mark that day. On our 10 frames, we're just adding one dot, aren't we? Because it's just our very first day. We have many days to go in July. So when I'm thinking about this, how many more days until we get to July 5th? Can you look at our frame and tell? That's right. 4 more days and we'll be at July 5th. How many more days until we reach July 10th? Can you use the frame to help? Just one filled in. So that means 9 more days until we get to July 10th. So today's number is a small one, 1. So let's go ahead and get our number of the day going. So 1, some people say 1 is the loneliest number. 1 is a 1-digit number, 1, right? How do we write 1 as a word? It sounds like it starts with a W, but really it starts with an O. O-N-E. This is how we spell 1. Now, how could we write 1 and represent 1 in some different ways? Well, we've been thinking a lot about dot patterns and dominoes lately. So could we represent it like it is on a domino? Sure we could. On a domino, 1 has 1 dot on one side and 0 dots on the other side, right? What's a number sentence for that? 1 plus 0, right? 1 plus 0 equals 1. What's another way that we could represent 1? What if we had a domino that looked like this? It has 2 dots, 1 plus 1. How would we change this to just 1? We'd take 1 dot away, right? So we could represent this with subtraction as 2 minus 1, right, will equal 1 for us. We can also think about our frames, right? We talked about if we have 1, how many more do we need for 5? So we could use subtraction for that. So 5 take away or minus 4 also equals 1, just like on the top half of our frame, right? 5 take away 4 is 1. Could you think of a number sentence for subtraction that uses 10? Let's try 10. What would our problem be that would equal 1? 10. How many are missing? 9 are missing. So 10 minus 9 also equals 1. And our frames help us with that, don't they? So now thinking about our hundreds chart, 1 is kind of a little funny to place on here, right? So we'll put our 1 here in the middle. Can we jump back on our hundreds chart from 1? Can we jump back 10? We really can't. So we're going to leave this empty. Could we jump forward 10? Sure we could. What is 1 plus 10 more? It's 11. So we started today with our big jump of 10. Now, what comes right after 1? You know that? It's 2. And what comes right before 1? There is something, isn't there? There's something that comes before 1 on our hundreds chart. That's right, it's a 0. Nice job, boys and girls. Oh, that's right. We forgot to talk about our days of the week. So today, the first day of July, is a Wednesday. So let's swap these around. Today is Wednesday. Then what was yesterday? Yesterday was Tuesday. And what day of the week will it be tomorrow? That's right, Thursday, or as some of us call it around here, Friday Eve. All right, we're gonna get out our counting jar now. Today our counting jar has bows in it. So let's get these bows out and see how many we have. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 13 bows today from our counting jar. Is that more or less than yesterday? Do you remember how many we had? Yesterday we had 16. So we could count back to figure how many less. 16, 15, 14, 13. 3 less in our counting jar today. So you know your work at home on counting jar. If you're a kindergartner, you are going to make a collection that's the same size as this one, 13. If you are a first grader, you're going to double that collection. So let's think about that. 13 plus 13. Well, 10 plus 10 is 20, right? And 3 plus 3 is 6. So that means first graders, your collection should have 26 things. And second graders, you are going to double the 26. So let's think about 20 plus 20, that's 40, right? And 6 plus 6 is 12. So if we put 40 and 12 together, that makes 52. So here are your counting jar assignments for today, and we'll come back to these again a little later. All right, so we didn't do any counting today because we're just on 1. So I wanted to talk a little bit more about dominoes because we've been thinking a lot about dot patterns and dominoes. So remember, we talked about on a domino, it doesn't matter, right? You can turn dominoes around. Here we have 5 plus 2. What's 5 and 2 more? It's 7, right? We could flip it this way and make it 2 plus 5, and it would still equal 7, wouldn't it? And we talked about this earlier in the week. Earlier in the week, we talked about how we could switch the add-ins around and we'd still get the same answer. So this is kind of important to know if you are counting to figure out how many. This is important to know because if you wanted to figure this out, it might be easier for you to think about starting with the 5 because you might have less to count if you're counting on. If we start this way, we'd have to count 2, 3, 4, 5, 6, 7. But if we start with the 5 and you're a kid who counts on, then we only have to count on 2 more. 5, 6, 7, and that's a little faster or more efficient. There's some other ways that dominoes certainly help me that I kind of wanted to talk to you guys about. So I can think about dominoes if there's a fact that I don't know, that I'm not sure. So what if all of a sudden I forgot 6 plus 4? I couldn't remember that fact, but I didn't want to count. You know what I might think of? I might think about taking one of these dots from my 6 and sharing it with my 4. And if I do that, then I have a new problem, and it's one that I know. It's 5 plus 5, which is 10. And 5 plus 5 is the same as 6 plus 4. I just thought about, in my brain, rearranging those dots, which is really thinking about changing up our add-ins to make simpler problems for us. Another way that dominoes can help me is I can use the patterns and think about other facts I know, even without thinking about moving dots around. So what if I didn't know 6 plus 5? How could I figure it out without counting? Well, I might think about 5 plus 5, because that's a fact I know, right? That's 10. And to add 6 on instead, I just add 1 more. 5 plus 5 plus 1 more gives me 11. And you all worked on that a little yesterday with Mrs. Obenshane when you were working with doubles, doubles plus 1, doubles minus 1. So sometimes thinking about frames and dot patterns can really help us find some ways to put numbers together without having to count them by ones. So let's just try out a couple, okay? So I'm going to show you quickly some numbers here, some dot patterns, and then you tell me how many you think. Ready? 2 under here, 2 more here. How many is that all together? You know that one because it's a double, right? 2 and 2, 4. Very good. Let's try just a couple more of these. All right, this time, 5 under here, 1 under here. How many is that? 5 and 1 more. Did you say 6? 1 more than 5 gives us 6. Very good. Let's see which one is next. 1 under here, 3 under here. This is one of those ones we might want to turn around if we're counting, right? So we might want to think about 3 first and 1 more. What's 3 and 1 more? It's 4. You've got it. So this is a fun way to kind of think about your strategies. You can look at dominoes at home and think about patterns you see and how you could put those dots together to get totals or sums without always counting them by ones. And now we're going to turn it over to Mrs. Obenshane, who has a fun task for you.
All right, good morning, mathematicians. We are going to do something called, let's see if I can remember how to. Get us to where we want to be. Nope, that's the, I did the wrong one, I think. Ah. One second, we need a password. All right, and we already did today's number, so we're not doing that. I've got a different activity down here for you. This one is called Placing Chips, and it comes from the U-Cubed website, which is a really fun website that you could explore with your parents. And what we're going to be talking about is place value. I wonder if I can. Not. All right, so I have a hundreds chart up here you can see, and we are going to be placing chips, just like the name of the problem suggests. So if we had 4 chips, for example, I'm going to give you an example, and I moved 2 of the chips here and 2 of the chips over here. Let's talk about what I am representing. So this box is the tens box, and this box is the ones box. And so if I have, I'll move these other ones, 1 10 over here, gotta move it all the way up, and then another 10, how much does that get me to? That gets me to 20, and then I have 2 over in the ones box. Whoops, I'm a little road. And so that should make 22. So we're gonna do some recording. I'm gonna move our July calendar. I can't believe it's July. That's just crazy. It's definitely summer now. And I'm gonna think about what we just did. So we said we have 2 chips in the tens. So we have 2 tens. And we have 2 chips in the ones, so we have 2 ones. And that number it makes the number 22 because we have 20 from our 2 tens and 2 from our 2 ones. Do you see it here? 10, 20, 21, 22. I also want to see about what that looks like when we're thinking about the quantity, because we don't want to just work with the numbers. We want to think about how much that really is. So how many tens did I say that I had? 2. And how many ones? 2 of those also. So that made 22. So I can see it here, 10, 20, 21, 22, kind of reminds me of our calendar. And I can see it over here. If I have 2 tens, 2 ones, it makes the number 21, and we know that because it's 20 plus 2. So the challenge of this problem is for us to figure out how many other numbers can we make with 4 chips. What could I do if I move some of those chips? I can only work with 4 chips for this one, for this challenge. I know I could make 22 with my 4 chips. What else could I do? Maybe I could move one of these chips from the tens over into the ones box, right? I'm still using 4 chips. Now I have 3 in the ones and 1 in the tens. So let's see how that changes our hundreds chart. Because we've talked about our hundreds chart a lot, right? And how if we're going this way, we're counting by tens because it includes all those numbers before it. And if we're going this way, we're going by ones. So what number do I get if I have 1 in the tens and 3 in the ones? 13, that's right. Let's record it. So we have 1 in the tens, 3 in the ones. It makes 13. And we know that because we have 10 plus 3. How does that change our frames? I need to get rid of one of these 10s, right? And then I need a card that has how many ones on it? That's right, 3 ones. There's our 13. Is there another number I can make? What else could I do? Well, what if I just kept moving those out of the tens? What do we have then? Now I've got them all over in my ones. So I've got 1 in my ones, a 2, 3, and then 4. What number does it make? 4, exactly. We have 0 tens, 4 ones, and that makes 4. I don't have to write the 0 if it's the number in front and it's not boxed in. And there are no 10s to add, just 0 10s plus 4 ones, right? So I would have to get rid of this 10, and I have all my 4 on one card. No more 10s if I have them all in the ones box. Have I made all the numbers that I can make with 4? Can you think of any other option? We've done it where we had 1 over here. I'm looking at our chart. We've done it where we had 2 over here. Have we done it where we had 3? I don't think we have. I'm looking, I don't see one that we have 3. So let's try that. What if we put, whoops. Oh, wow. What happened there? Undo that. All right. What would happen if I had 3 over here? So now I have 3 10s and 1 1. So let's write that down. 3 10s, 1 1s. So that's going to make 31, I think. 30 plus 1. Let's check it on the hundreds chart. So I've got 110, another one, a third 10, and then 1 1. Do we end up on 31? We do. And we can see how much that is. How many 10s do we have? 3. 1, 2, oops, that's not a 10, is it? That's a 9. 1, 2, 3. And how many 1s do we have? Just 1. There's what 31 looks like. Are there any other choices for us? Well, we know we've had 2 in the 10s place. We've had 1. We've had 0 dots over there. We've had 3. We haven't had 4. Okay, let's try that. And if I do that, what do I end up with? 4 10s, 0 1s. 40 is my number because I have 4 10s, which is 40, plus 0 1s. And that changes this over here into lots of dots, right? 40, do you think that one might be our biggest number? So, which is our biggest number that we made? 40. And which is our smallest? 4. So we made 4. And then what else did we make? What would be the next number? 13. And then 22, 31, and 40. I'm going to leave those there, and we're going to explore what would happen if we used 5 chips and see if we start to notice a pattern. And if we can't quite get there, this is something you can continue to explore. All right, so I'm right here. If I'm going to use 5 chips now, I'm just going to go ahead and put 1 more over in the 10s. So I've got all 5 of my chips in the 10s. So this is going to be a new set. And I have 0 1s. What number does that make if I have 5 10s? It makes 50. 50 plus 0. Okay, and what would I have to do over here? Right, I'd have to add 1 more 10. There's our 50. Maybe we can do this in a little more organized way this time, right? Here, I've got 5 10s. What if I just start moving them over and see what happens one at a time? So, if I move that over, I've got to move this over into the 1s. What number do I get now? 41, right? 4 10s, 1 1. It makes 41, and we know that because 40 plus 1 what happens over here? I have to take this 10 away and put a 1 in its place, right? Let's move one more. What happens now? I've got 3 10s, 2 1s. It makes 32. We know that because 30 plus 2 equals 32, and that's what's showing on our hundreds chart. Our number is getting smaller because we have to keep taking 10s away, isn't it? 32. What if I move one more? So now I've got 2 10s, 3 1s. It makes 23. We know that because 20 plus 3. So let's change our hundreds chart to show it. We'd have to take a 10 away, right? And add 1 to our 1s. That number is getting smaller and smaller. We're almost there. I'm going to do one more, and then I think we're going to have to just think about what happens next. So if I take 1 and I put it into the 1s, I have 1. I have 4 in my 1s place, which makes 14 because 10 plus 4, right? So what happens if I move that last one? I'm going to have 0 10s. I'm going to have 5 in my 1s, so I'll have just 5. The last thing that we're going to do, and then I'm going to encourage you to explore this yourself, is let's look at, actually I think I want to put these on this side. What we made. We made 5 and 14. I'm going to read it back up, right? Because that'll go from smallest to largest. 23, 41, 50. Do you notice any patterns in these numbers that we've made? Look at that. I see 5, 4, 3, 2, 1, 0. I see that same patterns in the 1s. I see a pattern in my 10s place. That's the same. And look, we have a pattern going across too. So what do you think if we were to use 6 chips? How many numbers would we be able to make? With 4 chips, we made 1, 2, 3, 4, 5. With 5 chips, we made 1, 2, 3, 4, 5, 6. So with 6 chips, I bet we would make 7. And with 7 chips, I bet we'd make 8, and you'd see a pattern. So tonight, you can get out your hundreds chart and think about your chips and see what kind of number combinations that you can come up with. All right, it is time for Miss Carnes to read us a story.
All right. There we go. Good. We're gonna use our computer to help us too to see some things from the story. So we're gonna pull that up here. Okay, great. So guys, today's story is a special one. It's called Grandfather Tang's Story, and it was written by Anne Tompert and illustrated by Robert Andrew Parker. And it's a dragonfly book. Now, something that's special about this story is, well, first let's look at the cover, actually. What do you notice on the cover? I noticed 2 people. Since the title is Grandfather Tang, I bet you this is grandfather. And this person here is the grandchild, right? It looks like they're sitting together outside What do they have in their hands? Do you see these black shapes? What might those be? If you've read this story before, you might have an idea. This is what makes this story sort of extra special, because what Grandfather Tang and his grandchild have in their hand is called a tangram. And there's a picture of a tangram up behind me, nice and big, so you can see it. And a tangram is a puzzle of shapes that you can use to make other figures and shapes, like animals or houses or other designs you want. In this story, Ann Tompert uses tangrams to help tell the story, which is a Chinese folk tale. So we're going to read it today, and we're going to finish tomorrow, and tomorrow we'll make some of the animals from the story with tangrams. All right. Grandfather Tang and little Sue were sitting under a peach tree in their backyard. They were amusing each other by making different shapes with their tangram puzzles. "Let's do a story about the fox fairies," said little Sue. So Grandfather Tang arranged his 7 tangram pieces into the shape of a fox. There's 2 foxes, aren't there? Because there's fox fairies. They will be kind of like tricksters in this story, sort of like Coyote is in New Mexico. Then Grandfather Tang made another fox with little Sue's 7 tangram pieces. Little Sue clapped her hands as her grandfather began. Although Chow and Wu Ling were best friends, they're the fox fairies, they were always trying to outdo each other. One day, this rivalry almost brought their friendship to a tragic end. They were sitting under their favorite willow tree beside a river talking about their magic powers. "I can change myself into a rabbit as quick as a wink," boasted Ling. "I'll bet you can't do that." "I can too," said Chow. "Cannot," said Wu Ling. "Anyway, actions speak louder than words." And he turned himself into a rabbit. "Not bad," said Chow, smoothing his whiskers, "but watch me do better than that." And before Wu Ling could blink, Chow changed from a fox into a dog. Now, when Chow changed himself into a dog, he not only looked like a dog, but he felt like a dog and he acted like a dog. Uh-oh. Do you have a feeling about what might happen? He bared his teeth and lashed his tail. Wu Ling shivered and twitched his nose because remember, Wu Ling is a rabbit right now. I think dogs like to chase rabbits. "I love rabbits," Chow growled, "and I'm going to get you and gobble you up." The dog edged closer and closer. Wu Ling's eyes grew bigger and bigger. He was too frightened to move at first. But then he thought, "I'll be safe if I can climb up the willow tree." His little puff of a tail grew long and bushy, and his tall ears shrunk as Wu Ling turned into a, what do you think? What has a bushy tail and can crawl up a tree? That's right, a squirrel. Wu Ling sprang into the willow tree and scrambled to the top. "Chow will probably turn himself into a cat so he can climb up the tree after me," Wu Ling said to himself. "But he'll never catch me. I'll jump from tree to tree and he won't be able to follow." Of course, Chow thought about changing himself into a cat. "But that's just what Wu Ling expects me to do," he said to himself. "What can I do to surprise him?" He thought and thought. "I know, I'll swoop down upon him from above." What do you think he's going to change into if he's going to swoop down from above to the tree? Some kind of bird? He turned himself into a hawk. Chow circled round and round in the sky above the willow tree, searching for Wu Ling. Wu Ling peered through the leaves of the tree, looking for Chow on the ground. Round and round, Chow circled the willow tree until he saw Wu Ling. "Kick, kick, kick," he shrieked as he zoomed down upon the squirrel. Wu Ling trembled. Chow's beak looked sharp enough to pierce right through him. If only I lived in a shell house, he thought, then Chow couldn't hurt me. Chow stuck out his fierce claws to seize Wu Ling, but as he dove, he tucked in his head and tail and legs, turned green, and changed into, what do you think? What lives inside a shell house? That's right, a turtle. Wu Ling climbed up on a mossy rock in the middle of the river. He thought he was safe because he looked like he was part of the rock. Chow circled round and round, searching and searching until his sharp eyes spotted the turtle. Then he swooped down, down, down toward him. But just as Chow reached him, Wu Ling plunged into the water. "Follow me and you'll drown," he cried. "Don't worry," cried Chow, plunging right behind Wu Ling. His body grew longer, covered with scales. He whipped the water with his long, wicked tail, and he snapped his spike-toothed jaws. What did he turn into? Scales, a long tail, sharp teeth, and he's underwater. That's right, a crocodile. Wu Ling circled round and round as he plunged down, down, down to the bottom of the river. Chow lashed his wicked tail as he plunged after Wu Ling, but just as they reached the bottom, Chow clamped Wu Ling in his spike-toothed mouth. "Now I've got you," he bellowed through his clenched teeth. "Oh, no, you haven't," cried Wu Ling, who grew smaller and smaller and changed himself from green into gold as he changed into, what do you think? He got smaller, his color changed to gold, he's still in the water. Aha, a goldfish. And he swam right out of Chow's mouth between his spiked teeth. Then he hid in a patch of cattails. Chow churned the water with his lashing tail as he charged into the patch after Wu Ling. With his head swinging back and forth and his eyes darting here and there, he searched for Wu Ling. Wu Ling knew that Chow would not give up until he found him. "I must fly from here," he thought, and he started to honk as he transformed into what could it be? Something that flies, and the noise it makes is honk. He turned into a goose. Chow charged after him, but Wu Ling spread his wings and took to the air. Chow watched him fly to a small island where a flock of geese were feeding. By now, he was not only very angry, he was also very hungry, because remember, he's a crocodile. He decided that if he could not catch Wu Ling, any goose would make him a good dinner. He splashed through the water toward the island until he reached it. "Honk, honk, honk," called Wu Ling, and he took to the air. A chorus of honks swelled the air as the flock of geese spread their wings to follow him. While Chow watched, the honking grew fainter and fainter. The flock grew smaller and smaller, and he felt his anger slowly drain away. "Why, oh, why do we play that stupid game?" he moaned. "I'll never see Wu Ling again." He closed his eyes and sank toward the river's bottom. But just as he touched, he had an idea. And we're going to stop the story there for today. And I would ask you to think about, what do you think is his idea? How will Chow make it so that he can see Wu Ling again and maybe end the game? I wonder what he'll change into next. So we have a few minutes. I want to kind of spend a little time talking about tangrams if we can. We'll be talking more about them tomorrow. So one thing I want you to know is that tomorrow, after we finish this story, we will use tangrams to make some of the animal shapes in the story, okay? And we have for you, with our resources, a template. That's something you can use to make a tangram puzzle. And you could print it out and cut out the pieces. There's going to be 7 pieces. If you can't print this out, helpers at home, there's also directions for how you can make a tangram puzzle just by making your paper into a square shape and then folding it so you can see where to draw in the lines to make the shapes. So even if you can't print, you'll be able to do this. And then we also will have a worksheet for you that has all the animal characters from the story to help you to think about making some of those shapes and how we would arrange our shapes to make the shape of an animal. So you may want to get at these resources before we meet again tomorrow. Let's see, we have just a couple of minutes, and let's see if we can just take a quick look at our tangram. Okay, so when you start a tangram puzzle, it's in the shape of a square, and all 7 pieces fit nice and neatly together in this square shape. So let's take a look at our shapes. Do you remember how many I said there are? It's always the same in a tangram. There are 7. Can you see the different shapes that we have here? How many different shapes do we have? We've certainly got triangles, right? So triangles are one of the types of shapes we have. How many triangles do we have? We have 4, right? And triangles are the same because they have 3 sides. These triangles are different. Oh, we have 5 triangles. Oops. These triangles are different because they are different sizes. We also have a square. Do you remember the special name we gave to a square? A square is part of a group of shapes called a quadrilateral. That's a shape that has 4 sides. A square is also a quadrilateral. And then we have this other shape here, which is also a quadrilateral because it has 4 sides. But it's not a square, is it? It's different. This shape has its own special name, which is called a parallelogram. So tomorrow, I'm looking forward to making characters from the story using our tangram shapes and also finishing up and finding out what is going to happen next in the story.
All right, are you guys ready to play a game? That is what we're going to finish up our morning with.
Almost ready. Let's see. Oh.
And I will let Miss Carnes find where we have that game.
Yes, we will find it.
And I'm going to show you some cards that are going to go along with it. So this game is called the Great Race for 5+. We've played Great Race games before, right? And we were talking about how versatile they are, and that means that you can change them a lot and use them for a lot of different things. So this one is going to be for adding numbers to 5. So not adding numbers to make 5, but having 5 and then adding numbers to it. All right, so I'm going to have you look at this 10 frame really quickly and tell me what you see. What did you see? Did you say 6? How many were on the bottom row? 5. And how many were on the top row? 1. And 5 and 1 is how much? 6. Exactly. Look at that again and make sure. Yep. Let's see, I'm going to move these around a little bit. Get your eyes ready. What did you see? Did you see 5 on the bottom? How many were on the top row? 3, and 5 and 3 makes how much? 8. Ready? What did you see? 5 and how many more? 5 and 4, and that makes how much? 9. And what about this one? 5 on the bottom row again, and how many on the top row? 2. So 5 and 2 makes 7. And then the last one of these that we're going to use, whoops, it's hiding from me, is this one. How many did you see there? Just 5, right? Half of the frame was full, nothing on the top row. So let's go ahead and stick these up here next to our equations. So 5 plus 0 is 5. Oh, nope. Doesn't want to stick. Five plus 1 is 6. 5 plus 2 is 7. 5 plus 3, 8. 5 plus 4, 9. And our last one, 5 plus 5, makes a full frame, right? So that's 10. So we can use these to help us with our game today. We've got a spinner over here. I have a dice that Miss Carnes can use. And this is the same game. We're going to spin that dice or the spinner. We're going to roll that dice or spin the spinner. And we're going to add whatever we get to 5. And then we'll move on our game board until one piece is in the middle. All right, go ahead and go first, Miss Carnes.
Okie dokie. I get a 1. So what's 1 more than 5? We can use our frames, or we can think 1 more than 5 is, you got it, it's 6.
I got a 0, so that's pretty easy, right? If I have 5 and I add nothing to it, I'm staying with 5.
Okay. This time I got a 2. Oh, that's going to be 1 more than I got last time, because I had 5 plus 1, and now I have 5 plus 2. So how many is that? 7 it is.
And look at there, I spun the same thing that she did, so we have another 7. 5 plus 2 is 7.
Well, I rolled a 1 again. What's 1 more than 5, guys? It's 6.
Not getting any high numbers, are we?
Mm-mm.
Let's see what I get here. Oh, 5 and 0 again. Well, we'll see. Although this game, you never know. You think you know what's going to happen. You think you know which number is going to win.
I got a 3 this time.
Oh, there we go.
So where do we see 5 plus 3? I see it here. And I might know it's 8, or I might also think about 10 frame and 2 are empty. So that's 8.
All right. And I got a 5 this time. So 5 and another 5, right, is 10. Well, all I needed to do was say we weren't getting any high numbers, I guess.
And now my die is being a copycat because I also got a 5. So what's 5 plus 5? Good old doubles. It's 10.
I got a 2. 5 and 2 is 7. That's right. 7 looks pretty good. What number do you think's gonna win?
I rolled a 1 again. 5.
Oh.
5 and 1. 6. Yes. Yes, yes, yes.
I got a 2 again. Same one as last time. 5 and 2 is 7. I don't know. I'm feeling pretty good about 7. What do you guys think?
I wish we could get 9 in the game. What do we need to get 9? We need what? A 4. But I rolled a 5. So what's 5 plus 5? It's 10. Close to 9.
Maybe I'll get a 4. Nope. 5 plus 1. We've seen that one a lot. 5 and 1 more is 6. Ooh. Which one are you rooting for? Do you want 6 to win or 7?
Oh my goodness, I rolled a 2.
Ooh.
5 and 2 more. That's right, it's 7.
Look what I rolled. 5 and 2 more, so 7 is the winning number.
That was a
fast game. Well, I guess we have maybe enough time to see if we can get 9 in the game.
Oh, that's
Try
a good idea.
again.
Well, I rolled a 3. So 5 and 3, that's not going to get me 9. It's close. What does it get me? That's right. Gets me 8.
5 and 0, what's that? 5. When I have 0, it doesn't change at all, does it?
Copycat, 5 and 0. 5 plus 0 is still 5 because we haven't added anything to it.
Okay, 5 and 4. That's what we've been looking for, right? 5 and 4 makes 9. I can see that because it's 1 less than the 10. All right, 9, you got into the game this time.
Okay.
Maybe 9 will be the winner.
I rolled a 3 again. So what was 5 and 3 more? It's 8.
And I rolled a 0 again. So 5 and 0 stays 5.
I rolled a 4. What's 5 and 4? It's 1 less than 10, isn't it? So it's 9.
Did you see what I rolled? Or I spun, I guess. I didn't roll. A 0 again. Oh, looks pretty good for 5 this time.
3 again. 5 and 3 more. It's 8. That's right. Oh, this time we have a few numbers that are
5
left
and
out.
5. Well, I'm going to add 10 into the game right now.
Yay. I rolled a 4 again. So 5 and 4. There it is. It's 9. 1 less than 10.
Ooh, 5 and 0. Boy, 5 looks pretty good this time around.
This time I rolled a 1. We rolled that a lot last time. So what's 5 and 1 more? It's 6. That's right. Everyone's in the game but 7.
5 and 5. That's 10. We know that double.
I rolled a 4 again. So 5 and 4 more. Do you remember it? It's 9.
I'm feeling very happy for 9 this time around.
But sad for 7.
But 7 won last time. So, sometimes that just happens, I think. 5 and 3. So 1 less than 5 and 4, right? So it's going to be 8. 8 looks pretty good too. I just hope a different number wins this time.
Yes. I rolled a 5, so that's a double. 5 plus 5. That's right. Think about all fingers up or a full frame. That's
All right,
10.
I think this is all we have time for is one last spin. We'll see. Up 5 and 5 is 10. I think this time we have to say that maybe the 5 was closest to winning, but at least 9 got in the game this time, right? All right, we're just going to kind of summarize what we talked about today. We're in a new month, the month of July. That's great. In your counting jar, you counted 13 bows. If you're a first grader, you could try to make 26 of something, count up 26, and a second grader, 52, or you can try any of those regardless of what grade level you are. But there are some different numbers for you to try counting. What else happened today? We read a book about tangrams, and you're going to explore that more. And then we reviewed our 5 pluses, and we talked about 10s and 1s. So what a great day. We're going to have to wrap it up. So thank you for joining us today at APS, at Home with APS. See you tomorrow.